Okay. So then, if you guys can see my screen, what can you see? Minor?
What I can see is indices.
Yes.
And the learning objectives, which are 1, define the indices and logarithms. 2, state laws of indices. And 3, apply laws of indices in calculations.
Okay, good. So that's what we're going to discuss tonight. And basically, as colleagues have said, the learning objectives are to define an index. So it should be indices, not logarithms, please. Then you state the laws of indices, then you apply the same laws in calculation. So I hope all of us will enjoy this session. So we go to the next slide. I would ask one of us to read what he can see or what she can see from your end. Brenda, can you read for us what you can see from your screen?
Introduction. What does 2 raised to power 4 actually means?
Yes, what does it mean from what you can see?
It is you multiply 2 4 times.
Yeah, so as my colleague there said, 2 power 4 essentially means we are multiplying 2 by itself 4 times, which then gives us 16 as a figure. Okay, so what we're going to do is we're going to zero in on this thing here, 2 raised to power of 4. And so in our next slide, we're going to discuss more about it. And then as a continuation on what we're doing, who else can read for us what is saying on the screen? Clavius Ruto. Clavius.
Hello, what I can see on the screen is how can we write 2 multiplied 4 times? This can be written as 2 power 4.
Yes.
Which is 2 times 2 times 2 times 2, written in index notation.
Okay, thank you, Bwana Clavius. So 2 times 2 times 2 times 2 can be rewritten as 2 raised to power of 4. So this 2 raised to power of 4 is what we call the index notation. So then where 2 simply implies that is the base and 4 is an exponent or otherwise an index. So then we can move forward to the next slide and see further how we can do operations in regard to indices and see how we can apply various laws so that we see how we can operate. And operation simply means we are doing multiplication, addition, division, and maybe to see how the powers can also be applied in indices. So then we go to the first slide. The first slide is, okay, the next slide that is on laws of indices. And we have various laws, and law number 1, as you can see from your screen, is, Ian, what can you read from your screen? The law number 1. Ian, are we together?
Yes, law number is multiplication rule.
Multiplication rule. Okay, what does it state?
Yeah, a raised to m times a raised to n.
Yes. What do you get? Okay, as one of us has said, rule. Sadi, you can proceed.
Yeah, multiplication rule.
Yes.
There we can see we have a common base A, and the different bases have a power, a different power.
Yes.
Therefore, when you're multiplying such an index, you take the base and then you add the powers m plus n. Example there, we are seeing 2 to the power of 4 is being multiplied with 2 to the power of 3. Therefore, we take our base 2 and we add the powers 4 plus 3. We get 2 to the power of 7.
Very good. So ideally, as Sadi has said, if in any case we have the same basis and the powers are different, so we retain the base, and for this case, the base is A, and we simply add the powers. And we have an example there as been illustrated. So 2 raised to power of 4 times 2 raised to power 3, you'll realize that 2 and 2 is to the same base, then you simply add the powers. Then you get 2 raised to power 7. Okay. Then we have another rule or another law, which is the division rule. Mwangi, what does the division rule state?
The division rule, having an index of having common indexes, having two common indices, that is A. One has an exponential, one has a power of m. You divide it by the other one having a power of n. It is equal to the index, which is A. You then the first m, you minus the n. So having the example, that means having 2 to power 4, you divide by 2 to power 3. It means that you're going to it's going to be 2 to power 4, 2 to the power of 4 minus 3, and that is 2 to power 1.
Very good. But just a point of correction. So A is not an index, but A is a base raised to an index of m and n. Okay.
Oh, sorry for that. Yeah.
Okay, good. So that's a division rule, and the same case applies. So long as the bases are the same, then you simply subtract the index. So we can proceed to the next rule. So who can read for us the next rule? Brenda, are you there? Any volunteer, please, to take us through the next slide?
The power over
Brenda, please go on.
Power over power rule.
Yes.
We have a base raised to a raised to n, and then multiply by the powers are a, the powers are n and m. Now to use power rule, you multiply the powers. A raised to n times m. An example, we have 2 raised to power 3 multiplied by power 4. Then you multiply the powers, that is 3 and 4. It becomes 2 raised to power 12.
Good. As Brenda has put it, so when you have a power, the 2 powers, so we have a raised to n and again raised to m, you simply multiply the powers and you get your answer. So we can get to another rule. So this rule is called the negative power rule, or simply a reciprocal rule. So if you have a raised to a negative, then you'll have 1 over a raised to that power, but without the negative. So we have an example there, 2 raised to negative 3. We'll simply have it as 1 divided by 2 raised to the power of 3. And you'll realize that 2 raised to the power of 3 is same as 2 by 2 by 2, which then gives you 8. So your answer will be 1 over 8. Okay?
Yes.
So then we go to our last law, which for this case, we will call it a fractional law. And fractional law, we say that if you have a base raised to a fraction, and for this case, a fraction, tentatively, we are saying it is n over m. So if you have it as in this form, then this will be equivalent to taking the mth root of that number, which is a, then you raise it all to power of n. Okay, so can you all see the example down there?
Yes.
yes.
Okay, good. So it is 2 raised to 4 over 3, which then, according to the law here, it will be a cube root of 2. Then whatever you get here, you raise it to the power of 4. Then you'll get your answer. Does anybody has any question as far as this is concerned? Before then we proceed. Okay, so I think we can proceed and we do a summary of our discussion today. So I would request a volunteer to kindly take us through the summary of what we've discussed today. But then before we do so, I would like to ask a very simple question to one of us. Sadi, are you there?
Yes.
Sadi, what do you think you've learned today?
Today I've learned about an index.
Yes.
I've learned that it is a number to which a base is raised.
Good. And to my good friend is it Joseph? Is it Joseph? Joseph or sorry. Ian Tanui. Ian Tanui, what else have you learned today?
I have learned the laws of indices through multiplication.
Okay, so Tanui have learned the laws of indices through multiplication. So that's one of the laws. Mwangi?
I've also learned another law, which is the division law.
The division law. What does it state anyway?
The division law states when you divide, having a common base, when you divide two bases having different powers, it means that you are going to, it's simply that base, using that base, you minus the powers and get the results.
Okay, good. So that then brings us to the end of our class today. I want to thank all of us for participating. You can all have a good night. Goodbye.
Thank you.
Goodbye.
Good night.
Goodbye.
And goodbye too.
Misati umekuja late sana.